or with sound. Hey there, how are you? Today we're going to be just doing a brief video on solving simultaneous equations graphically. This is something which is in the higher tier GCSE, so hopefully if you're here you already know how to draw graphs. If you don't, I suggest you go away and learn how to draw graphs as well, because I don't want to spend time in this lesson talking about how to draw graphs in the first place. So we're going to go straight into it and see you in a second. So hopefully this will be something that people want to do once they're revising for their GCSEs and things. So you can see on the screen what I've got is two different equations. The equation of y equals 3x plus 1 and the equation of y equals minus 2x plus 5. And they are straightforward, their equations are there. Now what we can do, if we were to draw the two equations onto the same graph, so I'm just looking out for points of similarity here. So we've got 1, 4 and that there, and that should be enough to draw a line starting about there. So it's going to go, it goes through minus 1, minus 2, something like that. So there we have the two lines now on top of each other. Now to solve equations graphically, all you are doing is identifying the point on which the lines equal each other by where they cross. The reason this is the case is because every equation in the world is a mapping. It's a machine that maps x values, go through a machine and get y values out. That's all an equation is. So 3x plus 1 is all the values. You get a value 0, 3x plus 1, it gives you a value y. And the coordinates that are on there, for example, 2 goes to 7. So 2, 7, because the x value, when you put 2 in, 3 times 2 is 6, plus 1 is 7. You get the y out. They're all inputs and outputs. Therefore, what this point where they are overlapping tells us is that that's the point at which the same input works with the same output for both lines. Excuse me. Feels like I'm sneezing every lesson at the moment. I would then estimate that at about 0.8. I estimate that at about 3.4, something like that. 3.4. That would be a solution. 0.8, 3.4 would be a solution to these two lines. Now, if I had used an algebraic method, I'd get an even more precise answer. I'm going to demonstrate what I would have got using algebraic method. I'm assuming you've all done this before. If not, go back and watch some easier videos before you try and tackle this. 3x plus 1 is y, and y equals minus 2x plus 5. We can subtract one from the other to give us, that's 0 equals 5x, because if you take away a minus, it's a plus, 5x, and 1 minus 5 is minus 4. So we can then add 4, 5x equals 4. I'm quite pleased with myself here, because x actually does equal exactly 0.8. I now put it in. Y equals 3 lots of 0.8 plus 1. 3 lots of 0.8 is 2.4 plus 1 is 3.4. I mean, I don't quite know how this has happened, but it is exactly the correct answer. I did not prepare that, and I never normally get things right. So I am super happy with that. We have got the exact answer algebraically that we got graphically just by looking at the graphs. So the whole point of this lesson today is that the fact that we can use this just to look at graphs in this way. Now, I believe the next thing I'm going to do, I believe the next thing I'm going to do, what I can also do is I can do something like this, not using the highlighter, Mr. Harris. Y equals 3x plus 4 and y equals x squared plus 2x minus 3. Now I hope if I've done this correct and I highlight them and then I maths them, oh, so close, it nearly likes them. We had this before and I had to change the way I was doing x's. That's not a problem. I just change that x to an x like that and see what happens now. If I highlight them, this could still work. Maths it, and it's got what we wanted. Now if I put graph in 2D and insert it on my page, I have got those two equations over the top of each other. And what this demonstrates is that there are two solutions. And the reason there's two solutions, just like normally with a quadratic, there are two solutions because there's two places where it overlaps. Because it's x squared. X squared is likely to give us two solutions. If it had an x cubed, we may even have three solutions, or up to three. You're not necessarily guaranteed 2 or 3, and it is possible that to have no solutions, because it would be possible. I was talking to some of my year 10s about this morning. If you had a line like that and a line like that, that line doesn't cross there, so it would have 0 solutions. It is possible to have 0 solutions, but we've got one here with 2 solutions. What we need to do is make this a bit smaller and read off what those solutions are. I think that's quite accurate there. I'm going to use a straight line to try and pinpoint exactly where it goes here. And similarly, up here, the straight line. And nope, that wasn't neat enough. I'll move that over manually. Using the cursor, draggy, doesn't like it at all. Doesn't like it. No, it doesn't like that at all, so I'll have to draw on it manually. There you go, and across. So what we're trying to do is get the exact coordinates of this. So I think this first one is going to be the coordinate. I'm going to go slightly thicker. The first one's going to be the coordinate. I think it's going along 2 each time. So I think that's going to be 3, 14. That first solution. And minus 2. And it's gone down to about, that's 2, so we're going to go minus 2.5. Now obviously I don't know exactly if those are right, because the thing with graphical, it's not quite as accurate in terms of decimal places, but I got lucky on the first one, so let's just assume that it's quite good. But what I'm expecting to see when I'm seeing students doing this sort of work, I'm expecting to see the lines drawn on there. It's important to show where you found those calculations from, so by drawing on the actual graph itself. Not just reading, but drawing off yourself exactly where those points have come from and where we've got those coordinates from. And there's 2 solutions there to this equation. Now, it can even link to the work we did last week. Because last week we talked about, what about if it was y squared plus x squared equals 9 and y plus x equals 4. Now I might have to do the x again. We've already seen this already today. It nearly likes it. It nearly likes it. We'll rub out that's not a z and that's a smaller y. But it's not far off. Y squared plus x squared. Let's try again. See what it does here. Maths it. It's still saying z instead of 2. We're so close. Right. Let's get rid of this. And we want to really curve that 2. Let's see if it likes it now. Don't circle it like that. So we're trying to get one with a circle, if we can remember the lesson. There we go. Now if I solve it, it does tell me the exact solutions, but it won't let me draw the graph. So this must just be a thing on this thing. But the graph would look a bit like this. I can tell you what the graph would be. So what I can do is I can draw this, and I can draw the other graph over the top of it. I'll maths that, draw the graph, which is just like this. Insert that on the page, make it nice and big. And then the circle, if we think back to our lesson last week, was saying that it's going to be 3 and 3. And so something like that circle there, because the radius of the circle is the square root of the 9. That tells us it's a 3, so there will be 2 solutions here. There and there. Maybe not quite those. I'm a moron. There will be a circle tool on here, which I could use and probably work. Oh, where's that gone? It's crashed. That's just what I was hoping for. Something like that. Not necessarily the thickness of line I was looking for, but maybe that's better. So you can see now the circle directly over the top of the line, and again, solving graphically will just tell us there are 2 solutions. One is here and one is here. We do the same thing we did before. We read off exactly where those solutions would be and exactly where those solutions would be, and it will tell us coordinates again. So I would say this is approximately 1.4, maybe 1.3. 1.3 goes to 2.8, or we've also got, and it's likely to be a similar thing, 2.8 to 1.3, and that's the cool thing about the circle one. They often have like the inverse solutions to each other. So there you go. Today's lesson has all been about how you can solve an equation graphically. Now in the description below I've linked a PDF of exam style questions on this exact skill, where you're just solving the equation graphically. That's what you want to do. Go away and do. Practice it. If you don't practice and you just listen to my sound of my voice, maybe you've joined this YouTube thing, you're trying to revise for your exams or you're trying to learn it, and you've come in and found this video. If you then don't go and do the practice, don't expect to learn it. I hope that makes sense. You've got to go and do the work yourself. It's not something that I can give you a free pass on. But hopefully all the teaching that I've done today has helped you with how it all works. I've been Mr. Harris. You haven't. Look after yourselves and take care.